What up, class? I'm gonna go over these problems here. So remember, you basically want to do this snail. So it always starts at the base of your log and goes to the other side of the equation and then goes back. And you make an exponential. You make like an exponential equation. So it's 2 to the what equals 1/2. Now, anytime that you have a power that's equal to a fraction, it's most likely that your power is negative, and then you just got to think about like what power this is. So like, for example, I'm not going to write it on this paper, but like, since 2 squared is 4, then 2 to the negative 2 is 1/4. And like 2 cubed is 8, so 2 to the negative 3 is 1/8. So then basically you want to look at the denominator, and 2 is 2 to the 1. So then the answer is -1. Oops, that was kind of uggo. Whatever. Alright, and then here, 2 to the what is 0. Well, nothing, you can't raise anything, any base to any power and get 0, so this is not possible. Here, 2 to the 1/2 equals what? Okay, and then when you raise anything to a fraction, it's that type of root. So like 4 to the 1/2 is square root of 4. 4 to the 1/3 is cube root of 4. 4 to the 5th, 1/5 is fifth root of 4. So then this is the square root of 2. Okay, and then this one's 2 to the 0 equals what? Remember, anything to the raised to the 0th power is 1, so the answer is 1. 7 to the what is 49. Oops. JK. So then that's 7 squared, 49. So what is 2? 3 to the what is 81. 3 to the 4th is 81. So the answer is 4. Okay, and then this is important. Anytime you have log of like the same base, then they cancel. So if like you have log a base, some base b, and then you have b to like, for instance, 100, right? These cancel and your answer is like 100. So like log base, so then here, log base 5 of 5 to the 7th, that cancels and you just get 7. Here, log base 10 of 10, those cancel and you just get 1.2. And then log base 2 of 2, those cancel and you just get w plus 3. Okay, so it says let y equal log base 2 of x, rewrite the equation so it begins with x equals. So just use the snail. So y equals log base 2x, so 2 to the y equals x. And they are equivalent. Right, you can rewrite any log equation as an exponential equation, or you can rewrite like any exponential equation as a log. Like, the idea is like 2 to the 3 equals 8, right? That's true. And so is log base 2 of 8 equals 3, right? That's the and that's the logarithmic version, right? Because 2 to the 3 equals 8. So this is true also. So that's an example. Okay, moving on to, so that's what I was saying, 5-69. So 4 to the third, right, is equal to 64, right? This is equivalent to this, where this is the exponent, and, right, so the base is important. The base of the exponent is the base of the log, right, and these switch places. So then, since the base of this exponent is 5, then it's log base 5, right, and then those switch places. So it's x equals, and then y. So it's an exponent with a base of 5, and then to the x. So then it's a log of 5, and then it's to the opposite. It's to y. Right, and then here you do the snail, 7 to the y equals x. Here, the base of 8, so it's log base 8, and then to the x, so it switches, so it's y x. Then here, log base, and then the base of this exponent's a, so that's the base of the log, and then it switches, so it's c equals k. And you kind of don't even have to do this one, right, because these are the same, so then a to k equals c. And then this one, the base of the log, right, so again, do the snail, so 1/2 to the n equals k. Okay, so here it says, make a table and complete the graph for the function f of x equals x minus 2, x plus 2. Right, you just plug each of these numbers in. So then, right, it's negative 3 over 2 minus 2, negative 3 plus 2. Right, so that's negative 5 over negative 1. So it's 5. This one you're going to get an error because negative 3 minus 2 over negative 2 plus 2, right? You're going to get 0 on the denominator, so that's a problem. Oops, negative 2 minus 2. Oopsies. Okay, negative 1 minus 2 over negative 1 plus 2. Right, you're going to get negative 3 on the top, and you're going to get 1 on the bottom, so it's negative 3. And then here you're going to get negative 1. And then here you're going to get negative 1/3. And then you're going to get 0. And you're going to get 1/5. And then you can like check your answers, right, with your calculator. It should turn on. Okay, so it's x minus 2 on the top, x plus 2 on the bottom. Right, you want to put both the numerator, and denominator there, and then you press graph. Right, it's a hyperbola. It's not the form that we normally see, so but there is an asymptote here at, we'll draw them. You have an asymptote at negative 2 and an asymptote at 1. And then you just plot the points, and you can check your table, right, that I did it correctly. So negative 3, right? 5, that's right. That's right. Negative 1/3 is the same thing as negative 0.3 repeating. 0, and then 1/5 is the same as 0.2. So did that. So negative 3. 5 is here. Negative 1 negative 3, 1, negative 1/3, 2, 0, 3, 1/5. Okay, I have a lot of points for this branch, but only 1 point for this branch, so should probably plot some more points here, like negative 4, 3, negative 6, 2. So here we go. There you go. Okay, alright, and then to make a table for the inverse, right, you just flip it, so it's 5, negative 3, error, negative 3, negative 1, negative 1, 0, negative 1/3, 1, 0, 2, 1/5, 3. Okay, and then to find the inverse equation, right, you flip x and y. Okay, and then you want to get rid of this denominator, so you multiply by y plus 2. And then when you distribute it, you get x times y plus 2 on the left side. And then the y plus 2 and the y plus 2 here cancel, so you get just y minus 2. Okay, and then you want to distribute this, you get xy plus 2x equals y minus 2. And then the goal really, because remember, we're trying to solve for y, so you want to take all of the terms that have y's in it, so like this one and this one, and you want to put it on the same side. So you move this over here and that over there. So then you get xy minus y equals negative 2x minus 2. And then you want to factor out this y. So then you get y, x minus 1 equals negative 2x minus 2. So like, and then, right, because that's the same thing as xy, just with the y taken out. Like if you redistribute this, you're going to get this. Like y times x is xy, and y times negative 1 is negative y. And then you just divide by x minus 1. So then you get that. So there's your inverse equation. Okay, and then last problem. The trick here, since you have exponents on the left side, is to make both of these have the same base. And like 16 and 1/8 are both powers of 2. So you can rewrite it as 2 to the x plus y, and then 16 is 2 to the 4th. And then 2 to the 2x plus y, and then 1/8, remember, so 8 is 2 to the 3, so 1/8 is 2 to the negative 3. And then once you have that, then you can just make the x1 is equal to each other. So you have x plus y equals 4, and then 2x plus y equals negative 3. Right, and then you can solve this anyway. You can solve these both for y and set them equal to each other. You can solve one of this for y or one of it for x, substitute it. But it's probably set up really to be solved through elimination. So if you like change this right to negative x, negative y equals negative 4, right, those cancel, and you get x equals negative 7. So then you're negative 7, and then you plug it in to find y. So like if I plug it in the first one, then you get negative 7 plus y equals 4. So y equals 11. There's your answer. Okay, that's it. Hope that was helpful.